Hi, my name is Ashish, and in this video, we will see the networks in Azure Kubernetes services. This will be a bit of the theory section because we covered how to deploy a containerized application to the Azure Kubernetes services. I wanted to cover the networks concept in Azure Kubernetes services. So let me just quickly log on to the portal and continue from there. I'm logging on to the portal. So as you know that the Azure Kubernetes service cluster would block the all incoming traffic from the internet to the cluster to assure network security. The workloads that you will deploy in Kubernetes are by default would not be accessible by anyone outside the cluster. To expose the application to the outside world like we did in the previous video, we need to open specific ports and then forward them to the services which are hosted inside the pods running inside those clusters. And inside pods, you would have your containerized application that is deployed onto AKS. The configuration of ports and port forwarding in Kubernetes is different from what you might be used into other environments. So on a VM, you will configure the firewall to allow the inbound traffic. Let's say you want to enable port 443, you would enable the incoming firewall rule to enable port 443 to allow the HTTPS traffic. But in Kubernetes, the control plane would manage the network configuration based on the instructions that you would provide. So in networks in Kubernetes for container, the configuration for containers is temporary. A container's configuration and the data in it is not persistent between executions. So after I delete a container, all information is gone unless it's configured to use a volume so that my data is persistent, because as soon as I will delete a container, associated information from that container would also be deleted. So and a deployment that I deploy onto the AKS is a logical grouping of pods. It is not considered a physical workload and it is not assigned an IP address, but each pod is automatically assigned an IP address. So when the pod is destroyed, the IP address is also gone. So that is why the manual configuration is a bit complex. So now Kubernetes has two network availability abstractions that allow you to expose any app without worrying about the underlying infrastructure or assigned pod IP addresses. These abstractions are the services and the ingresses that we did in the last video. And they are both responsible to redirect and to allow the traffic from external sources to the cluster. So now let me make a small diagram. So let's say that this is your deployment. This box is your deployment, and this is your service that you are deploying. This is your service A, and this is your service B to deploy. And in service B, let's say you have an IP address of 10.10.10.9.2. I'm talking about the service B. So in service B, when you are deploying, you have pods. So in this service, let's say I make a separate box for service B. You have pods. You have pod A, pod B, and the container is running inside this pod, right? So these containers have IP address of 10.10.10.2, 10.10.10.4, and 10.10.10.3. So this is dot 2, this is dot 4, and let's say you have one more container inside this pod, and you have 10.10.10.3. Right, so we define a service in the same way as a deployment using the YAML manifest file that we did in the last video. And in here, the service uses the same selector key as deployments to select and group resources with matching labels into one single IP. So a Kubernetes service needs 4 pieces of information to route the traffic. It would need a target resource. So I would have to have a target I would have to have this. I make a box here. So I would have a target resource, and then I would have the service port, then I would have network protocol, then I would have resource port, right? So I would have target resource, service port, network protocol, and the resource port. So target resource is defined by the selector key in the service manifest file. The value will select all the resources with a given label. And the service port is the inbound port for the application. All the requests come to this port from where the service forwards the request to the resource that I've deployed. And the network protocol, this value would identify the network protocol for which the service will forward network data. And your resource port, this value identifies the port on the target resource on which incoming requests are received. This port is defined by the target port key in the service manifest type. And then we have Kubernetes service types. So if I cancel this and then we have Kubernetes service types. And in this I have cluster IP. Then I have, let me do this so that cluster IP, then I have node port, then I would have a load balancer, then I have external name, right? So what would the cluster IP do? The cluster IP would expose the applications internally only. This option allows the service to act as a port forwarder and makes the service available within the cluster. And the node port, this value would expose the service externally. And your node port, this value will expose the service externally. It would assign each node a static port that responds to that service. This node would automatically redirect the request to an internal service of the cluster IP type. And the load balancer, this value will expose the service externally by using Azure's load balancing solution. When created, this resource spins up an Azure load balancer resources within your, and then and in addition to the exposure of the service externally, node port would assign each node a static port that would respond to that service. And also the load balancer expose the service externally by using Azure load balancing solution. When this would be created, the resource spins up an Azure load balancer within the Azure subscription. Also, this type automatically creates a node port service. And then you have external name. This value maps the service by using a DNS resolution through a CNAME record. And we use this service type to direct traffic to services that exist outside the Kubernetes cluster. And now if I rub this, and if I draw again, what would an ingress do? So ingress would expose the routes for HTTP and HTTPS traffic from outside a cluster to the service inside the cluster. We define ingress routes by using ingress rules. A Kubernetes cluster rejects all incoming traffic without these routes defined. So let's say you have this block of service, and then you have service here, you also have service there. And when the request is going on from internet and you do not have ingress, the request would be rejected. And whenever the request is coming and you have ingress rule defined here, you will be allowed through the ingress rule to interact with the service that is deployed in the AKS. I hope you liked this video and it was beneficial for all of you. If you have any queries, please mention them in the comment section, and I'll see you guys in the next video. Thank you. Have a good day.